In this video, we are going to talk about a concept called sets. We are going to define what sets are. We are going to describe some models for both understanding sets and being able to express them. We're going to apply these models to a couple of particular sets. And then we're going to discuss what it means to be the power set of a set. So a set is literally just a collection of objects that we group together. And by objects, we mean literally anything. They could be physical objects, like rocks and chairs. They could be more abstract things, like numbers or arrays. And whatever the objects are, they are called elements of the set. So here are a couple of examples. First example, this is a set of, I guess you could call them objects, the set of people in our class. Right? So that's more concrete. The set of natural numbers, that's a little bit more abstract. That includes all whole numbers starting with 0 and going on up. And the notation we use to denote that is a funny looking n. The set of integers includes all the natural numbers plus their negatives. And this is denoted by z. The set of rational numbers, that's the set of fractions of integers, is denoted by q, q for quotients. And finally, the set of real numbers, which includes both rational and irrational numbers, that's denoted by r. There are some other examples that you can find in the textbook. You can see some more notation there. Just look for where on page 27 where it says special sets. All right, so there are two basic ways that we can think about sets, think about understanding them, think about how we can write the sets. One is what I call the list model. We could think of the set as being a list of the items that are elements of the set. We could also think of a set as a rule, so we can use a rule model. So a set is a rule that tells us what items are in the set and what items are not in the set. If the item follows all the rules, it is in the set. If it doesn't follow all the rules, it's not in the set. So I'm going to apply this to a particular set. I'm going to define a set F in two ways, one using the list model, one using the rule model. We'll start with the rule version. And the rule I'm going to give for being in the set is F is the set of all people in my immediate family. The rule being in my immediate family. If you follow that rule, then you're in the set. If you don't, then you're not. So if we have a person and the person is in my immediate family, that person is going to be in the set F. If we have something that is either not a person or is a person but not in my immediate family, that it will not be in the set F. So that rule tells us exactly what the elements are in the set F. And if we want to do a list version, that one's pretty straightforward. We just take all the elements in the set, in this case all the people in my immediate family, and then put them in a list. Right? So we make a list of everything in F, and that will be me and all my kids. So just a note, however we describe the sets, they are literally the same set. If I say all the people in my immediate family, or if I list all the people in my immediate family, they are exactly the same set. The only difference is how we express those sets. All right, so now we're going to move on to some concepts that are related to sets. Right? So if you have two sets A and B, we say that A is a subset of B, and the notation is written there, if every element of A is also in B. So every element in A is in A, of course, but then being a subset of B means it's also in B. Now, it doesn't have to be the case that every element of B is in A for it to be a subset. So as an example, every natural number also happens to be an integer, which tells us that the set of natural numbers is a subset of the set of integers. If you look at F as being the set of my immediate family members, as I described before, and if you let E be the set of my extended family members, everybody in my immediate family is also part of my extended family. That means that F is a subset of E. And I want to emphasize very clearly that the elements of set can be literally anything, even sets. All right? So that's a little bit hard to understand at the beginning, but we'll show you some examples. Here is a set S that has, well, it looks like that set S has 4 elements. What, right? 1, 3, 4, and 5. But it actually only has 3 elements. So let's see if we can understand this a little bit. All right, so as I mentioned, S has precisely 3 elements. It has the numbers 1 and 3. Those are 2 of the elements of S. The numbers 4 or 5, those are not elements of S. They are elements of the set containing 4 or 5. And the set containing 4 or 5 itself is an element of S. So S, as one of its elements, contains the set containing 4 or 5. And hopefully this can help us understand now what a power set is. So power set starts with a set, we'll call it A. The power set of A, called P of A, is the set of all subsets of A. In other words, all the elements of P of A are the subsets of the set A. So just some comments to see if we can clarify this a little bit. All the elements of P of A are subsets, are sets, right? So they aren't individual elements of A, they are sets. If X happens to be an element of P of A, in other words, X is itself a set, any element of X must also be an element of A. That's just what it means for X to be a subset of A, right? The power set contains all subsets of A. X is an element of A. X must be a subset of A. So let's see if we can apply this to an example. We'll just do a little set here. We can maybe do some bigger examples later. A is the set just containing the 2 elements A and B. And what we want to do is, first of all, just find out what all the subsets of A are, and then put those into a list to make the power set. All right, so let's go ahead and find all those subsets. So one subset is just the set that contains A. That's going to be a subset of A. Also, the set that just contains B, that's also going to be a subset of A. A itself is a subset of A. So the set containing AB is also a subset of A. And then there's one more, which is easy to forget, my favorite set actually, and that is the empty set. That is the set that doesn't contain any elements. So the empty set is the set that has no elements. So the power set will then have 4 elements, and we just list them. It has the set containing A, the set containing B, the set containing A and B, and the empty set. So now is a good time to look at the activities for Introduction to Sets. It's on the PDF file included with this video. I should mention that even though it's included in the in-class activities, these particular problems will not be included on the quiz. The main purpose of these is to help build the understanding of the concepts that we've been talking here. I still encourage you to look at them, but just understand that they're not going to be on the quiz.